Okay, hello, and thank you for joining this talk. Let me introduce myself. Igor Golikov, I work for IBM CephFS team, and this is joint work with Alex Markuze, which also is my peer in the CephFS team. He will give some overview of some advanced features we plan to implement in the future. But the main topic of this session is subvolumetrics in CephFS. So it's a new metrics that we have introduced in the latest release, which basically reflects the state of the subvolumes and the operations as activity of the subvolumes in the Ceph cluster. So we'll talk a little bit about the motivation, and then we move to requirements and discuss the metrics, the actual metrics that we collect. I will explain the sliding window approach that we picked in order for the metric life cycle. We'll go over the high-level architecture, some basic implementation details, and then the metric exposure, and we will talk a little bit about our future work, our ideas for the next generation of the observability in the CephFS, specifically for MDS. So of course I encourage you to ask questions, to think about questions. I think it's open talk, so any ideas, any thoughts, any questions, of course are welcome. Okay. So the motivation, I think, is quite obvious. In the large Ceph clusters, usually they use a lot of subvolumes. And for example, ODF, NFS, Samba are mostly based on CephFS subvolume feature. So it means that subvolume is effectively a path in the system, if we put it simply. Subvolume is just a path. So when you collect metrics, for example, per client, as we did before this feature, so you cannot actually monitor specific hot paths or hot subvolumes in the system, and the cluster operators couldn't get this fine-grained observability of what's going on in the system and what are their bottlenecks in terms of specific paths or locations in the file system. And that's what actually the main motivation that that came from the field. So the requirements were pretty well defined. So of course we had to provide the metrics on the subvolume level. So the scalability is very critical because, as I mentioned, the big clusters can use thousands or even tens of thousands of subvolumes. So we need to be scalable in terms of having these metrics in terms of memory footprint. Sorry. Of course, minimal performance impact, because all of us know that any additional instrumentation usually that you introduce in your system usually has a performance impact. So if you turn off debug logs, like everything becomes much slower. So we don't want we don't want the new metrics to impact negatively our file system performance. Requirement was to keep him on memory, so we don't have any persistence for these metrics. So we assume that the users of these metrics, okay, for example, exported for Prometheus, they will keep the history if needed, but we just expose the, let's say, current state of the system. Consistent aggregation across MDS ranks. So in big clusters, we have a lot of clients that may use different MDS servers, right? So we want to have consistent view of these metrics. So it was very hard requirement for us. So we decided to do it in some specific way that I will discuss a little bit later. And this was very hard requirement, as mentioned. Of course, reusing existing metrics infrastructure. Our MDS servers already expose metrics for Prometheus via the admin sock command, so of course we will want to ride on the same infrastructure. And the last one is the automatical pruning of the metrics. So if you don't have the subvolume active, so there's no need to display any metrics. We don't want to display zeros, right? If some path becomes quiet, so there's no need to displace it because of the scalability issues, right? Because we have thousands of them, so we don't want to display like information for thousands of subvolumes that don't have any activity. Okay. As per metrics, so I think it's a pretty standard set of the metrics. So for each subvolume, we want to have the averages, IOPS, throughput, and latency, both for read and for write separately. So when I say average, we don't want to have like lifetime average because it doesn't have any meaning. So we use the sliding window approach, which is for the fixed period of time, right? This window of fixed period of time, I will describe it later. And then it allows us to make it more, let's say, real-time metrics that actually reflects the current state of the subvolumes. Sliding window. So the default value is 30 seconds. So it means that any path that becomes active in terms of I/O for the last 30 seconds will have these metrics available. So when the window moves, of course, so the metrics are accumulated within this window and it's averaged within the window, all the I/O operations. But if the subvolume becomes quiet and after, let's say, 30 seconds, we will just prune it. We will not see any metric for this subvolume. It will just not return anything in the JSON, in the dump. So this is actually how it's pruned automatically. So why was this decision actually made? First of all, to limit memory usage for scalability. The second one is to actually smooth short-term I/O spikes, right? Because you can say that we want actually to see, we don't want to see very raw data, right? We don't want to see trends in the metrics. So this was the reason. And predictable cleanup, of course. This is the most obvious thing here. So in terms of high-level architecture, of course, first of all, I think I forgot to put it on the presentation. Currently, it's implemented only for the Fuse client, for the user space client. So the measurement, of course, for each single I/O operation is made on the client. So the client periodically sends all recording ops statistics to its own MDS, right? The MDS that the client knows. And the MDS periodically sends all the aggregated metrics from all clients that sends to this MDS to rank 0 MDS. And the rank 0 MDS actually accumulates all of them to like all metrics for all subvolumes from all clients and all MDS servers. And this one is, and here we use a sliding window. Okay, so the sliding window lives in the rank 0. Why? The reason is because the performance counters that we use, that we actually expose via the admin socket command is usually used against the rank 0 MDS, okay? So this is the reason. And that's why we have the consistent view over, this is the big clusters, because there's only one place where you can see these metrics, performance counters, on the rank 0 MDS, okay? This is what the implementation highlights. I think that the most interesting part and the most challenging part in the implementation of the client side was, so how to determine whether the current, for example, if you do perform the current I/O operation, whether this path belongs to subvolume, right? Because client has no understanding what subvolume is. Client has no understanding. We didn't want the client to know, right? So we want the client to remain as tiny as possible and to decouple completely the logic. So the only thing that the client knows from the metadata messages that it gets from the MDS, so for example, before we want to write or read from the folder, so we need to ask for the permissions, right, from the MDS, for the gaps. And in the reply, MDS can say this specific path belongs to subvolume X. And now clients knows for this specific path, you need to start to accumulate the metrics, okay? So if the client is working on some path that is not under any subvolume and defines subvolume, it will not just the metrics will not be taken. Okay. And so we use the metadata reply from the MDS. And in the MDS, so we put the flag, and we say, hey, this specific path is under the subvolume, so start measuring it. Okay? So in the basic unit of I/O measurement for the client, we have a very simple struct. It's just one field, 64 bytes, packed data, where basically it's just a MSB is a bit of read or write operation, whether it's a read or write operation. We use 32 bits for latency in microseconds for a specific op, and 31 bits for the payload size for this specific op. So imagine on the client, for each subvolume, we keep a temporal list of these units, right, of these specific, units, where we measure single I/O operations. So when the periodically client dumps all these lists to the MDS, of course it's clean from the client doesn't have any history, anything left on the client. And the next struct that we actually use on the MDS, on the rank 0, to be precise. This is aggregated I/O metrics. I think it's more or less self-describing, self-explaining in terms of what information it holds. We have the subvolume ID, read count, write count, read bytes, write bounds, and the latencies. Okay? So this struct is used to carry information, to hold the information per subvolume, right? It is aggregated metrics, and it can, for example, describe the last thousands of operations from a given subvolume from many clients, okay, that may perform I/O on the same path. Metric exposure, I think it's pretty simple. I think that we aimed for unified exposure via the standard interfaces that we use for MDS, admin socket. So the metrics are dumped and they're exported to the Prometheus. You can query the metrics with the CephDaemon MDX 0, for example, perf dump. And here you can see the JSON example of the metrics. So we include the file system name, we include the subvolume path to make it clear. And then we have the set of metrics for the subvolume. Of course, this information is available in the manager module as well. And eventually, it's not implemented yet, but yes, it will end in the CephFS top utility, which is a part of the utilities for the cluster. Okay. As for the future work, so as I already mentioned, we are currently evaluating the approach for the next generation of the observability and traceability and debuggability of specifically of CephFS. So I think that the next, let's say, low-hanging fruit could be the subvolume metadata metrics, because the metrics that I mentioned right now are for the data path only, not for the metadata, but we can start measuring the metadata-related metrics as well. I think that the second thing we can easily implement, if needed, per path metrics, because eventually submodule is just a path, is a system. And you can think of a very easy feature when you have a list of like hot paths that you want to monitor explicitly without working with subvolumes, right? So you can think of some configuration file that you can use, that you can say, hey, I want to monitor these paths, and it's very easy to implement. It's just a matter of some client work here. One of the options of upgrading the quality of metrics are using histograms instead of averages, which definitely can bring us some benefits and to understand better the distribution of latencies, because even for the small sliding window, right, if you measure latencies in a big system, it may be very noisy, and it may go for vary differently from client to client for specific subvolumes. So the average still, by the way, we use weighted averages for calculation, but still with weighted averages, I think histograms can do much better work for us. Of course, K-client support. This one is, I think, on our roadmap and definitely will be implemented. And the next, big topic that my colleague will jump in right now, it's a brief description of our future approach to anomaly detection in the MDS. So it's yours. This one is forward.
Hi, folks. My name is Alex. So K-client should be coming out in upstream soon. The won't be too long. Let's talk about all the metrics that we're gathering, right? And besides this, Igor has different other plans. So we have this huge inflation of metrics that we collect currently and will be collecting in the future, just to get it, like, who's here a client and has Ceph clusters deployed? Do you actually understand what the numbers mean and how to use them? That's a great answer. You have a petabyte of files, right? Am I wrong? Do you know what the numbers mean? No. Okay. That's great. That's the motivation for what we're doing. Okay. So we want to talk about anomaly detection, right? I shamelessly stole some figures from an IBM site, so don't try to figure it out. It's just an illustration. So what's an anomaly detection? We want to basically create a CSV, right? And try and see which of these lines don't look as the other, right? That's an anomaly detection. So there are two types of ways to go about it. One is via neural networks, and there's an IBM Granite time series detection tool that you feed a time series data into it. And here's an example. They're trying to see if they can spot an anomaly in sales in some Seattle locations, right? The correlation between the anomalies and the sales are not actually clear to me, but I'll give them the benefit of the doubt. But this is a time series anomaly detection where every new row has its spot in time. So something that came before, and something comes next, and we want to see if we can integrate it into analyzing matrices and trying to understand if we can gather some insights, or even if we can get, hopefully, some predictive insights, right? You can get an anomaly before something bad happens. That's the hope. We do need, we'll need some collaboration from you folks. So if you collect this data, you have some logs, and you can want to help us, we can use this real cluster data to try and see which of the anomalies that we see are actually anomalous and what is useful and what is not, right? Because getting a signal is nice, but how does it connect to any real-world scenario is still a mystery to us, right? So there's neural networks, and we plug in some IBM stuff, and the actual way we want to do it is through a isolation forest, which is time invariant. Each entry is just a data spot, is data vector that it's unrelated to any time spot, but it can see anomalous multi-dimensional data. This is two-dimensional because I had trouble doing higher dimensions here. This is again shamelessly taken from the Extended Isolation Forest original paper. It came out 7 years ago. And basically what you see here is the distribution of data. And it's unlabeled data, it's just a spot. It's not labeled in any way. You just mention that this is how the data looks. And what you see below is basically the heat map, right? So what's hot is what's usual, and what's cold is unusual, and you get an anomaly number, like a probability, but probably won't be a probability itself. We can normalize it probably by numbers, but that doesn't really matter. So this is what we want to try. But what can make it better is inputs from you folks. So if you want to share any anomalous behavior from your clusters with the metrics and maybe logs. We were thinking about doing some interesting things with, and had actual ideas on how to vectorize your logs, the metadata of your logs, and see if we can correlate it to something interesting as well. That's it. Any questions? You joined the...
Yeah, sure.
Yep. So you mentioned that this is available for the Fuse client, or did you say libCephFS?
Well, the metrics.
Yes.
It's a feature of, it's currently implemented like libCephFS used internally Fuse client, like user space client,
Yes,
right?
yes.
So if you mount user space client, you'll get these metrics.
Yes. So would, for example, these metrics become available through NFS Ganesha as well?
So the question is, in general, it should be. In general, it should be. So I think that the NFS Ganesha, we didn't try it yet, but there is no reason that it should not work.
Okay. Nice.
Yeah. You've tried it, so we have already the evidence that it works with
Nice.
Ganesha.
Yeah,
Sure.
Cool.
I think firstly a very wonderful work done. The question that I have is that we are choosing a sliding window or a 30 seconds average, right? Can we keep it raw and leave it to the customer to decide how they want to do averages?
Yeah, it was on the presentation, just did mention it. Yes, there is a configuration variable,
Okay.
right? I can go back to its name. Yes, it's configurable. We can make it so customers can use, using very large windows doesn't make any sense because usually the averages may become, very misleading, I can say, right?
Yeah.
So you better should keep smaller windows. But if the cluster is not so noisy, right, and you know that your subvolumes are more or less behaves normally, let's say, you can use better, larger window, bigger window, to get more metrics in view.
Yeah.
Yeah, but for noisy clusters, for this, I would recommend to keep small values.
Yeah, I think main reason to ask that is that the client level views, right, like Grafana or anything, right, they already provide averages and doing a lot more mathematical operations. So I think maybe keeping up to the customer thing, okay, you decide how you want to do it. Yeah.
Yeah.
I think I have another question then. Rather than you deciding it for all the subvolumes or all the data paths, right?
Yes.
Can
If subvolume, so yes, if it is enabled, if you have subvolumes, you have operations of subvolumes, you have these metrics.
Yeah.
By default.
But can a customer choose that, okay, I want to enable it for 5 of these volumes, subvolumes, and then leave all the rest?
Yeah, this is exactly what I mentioned in our future work. Well, it depends on the requirements from the field. Technically, it's not a big changes that we should implement in order to support custom paths, actually to observe, but it depends on the requirements from the field. If we'll get such requirement, we can be implemented, yes.
Okay, thank you.
Sure.
Yes. So I had another question. You mentioned as one of the initiatives or requirements that you had that comes from Kubernetes clusters with CSI drivers.
Yeah.
CSI provides volumes or in the namespace of an application. Is there a way to correlate this namespace, this particular PVC or PV, with what you get as metrics? Because they are called different.
Yeah, I understand the question. I'm not sure that right now we have this correlation in the metrics, in the output of the metrics. So the only thing we have is file system name and the subvolume path. So if you can use a subvolume path, if you make, for example, if you use groups, if you have named groups for subvolumes, when you create a subvolume, if your group name is something like something that you want actually to filter or sort on, you can use maybe group names, and then you can see this group name in the
Right,
metrics, and you
would need to
somehow
filter the
correlate
path.
it.
Yeah.
Yeah, by the path, but we don't have
Okay.
any other correlation right now.
Okay. Yeah. Thanks.
Right.
So the granite time series seems very interesting. Which, I was just looking, there's like flow state and tiny time, there's a bunch of things. So which, do you have any more details on exactly what you were using with that?
What do I mean?
Like which model?
There's a model for impulse for exactly for anomaly
Impulse.
detection.
Okay, impulse.
Yeah.
Okay, cool. And I assume this is all open source?
It should be. It's it's an IBM tool, so we can get access to it. The model actually, the model itself is on Hugging Face, so you can get it. So it's open source, yes.
Hello. Well, first, thanks for this. I think it's really cool. This having the metrics for CephFS. My question is: would it be possible for Prometheus to expose these metrics as counters instead of calculating yourself the average?
The problem is, yeah, we discussed this question internally, and the point is, so you want to have like list of latencies. So in order to calculate something, you need kind of list of raw values, right?
No, I mean normally in Prometheus world in general, Prometheus is very good already calculating the average per second with this rate function.
Yeah.
So at the end, the only thing you need is a counter of the number of bytes read by this particular subvolume. And with only that, in principle, the user can basically create the average or gives more flexibility to the client to create a plot they want.
Yeah, but in this case, I think clients should provide all the single I/O operations, right? The list, the vector of this operation, this vector could be huge.
I mean, in general, you need just
somehow
to have
aggregate
one metric per subvolume with the sum of all the bytes read for that volume.
The
for
sum
example.
of all the bytes.
Yes.
But you should have the distribution per time. You cannot assume that sum of bytes is distributed equally on the period of time. This is the point. You'll get misleading metric. Right?
Yeah.
That's the point.
Okay.
Yes, because we correlate. We know for each single operation because we do weighting, average inside. You see?
Okay.
Yeah. Thank you.
Is this the metrics aggregated for all the clients, or it's per client basically?
No, it's overall metrics per each subvolume from all clients.
So how I can identify, like suppose this subvolume is mounted on 2 nodes.
Yes.
One I might have a better performance on one client, so other client I might not have.
Well,
so how can I?
Yeah, it's a good question. I think that the initial requirement was aggregating from all the clients. I think maybe in the future release we can add some there are per clients metrics already exists in the MDS. So if you do the perf counter dump, you'll see the section in the JSON that relates for clients. So there's a specific class that describes all the clients. So maybe we can find a way to correlate somehow in the output the client and the subvolume metrics, but not now. But that's a good point. Thank you. I think we are done. Thank you very much, folks, for attending. Thank you.